that is one thing which I've noticed now in larger companies who are using monorepos, where just using Git as a source control itself is getting very, very challenging at scale.
This is DevOps Paradox, episode number 203, Dealing with Flaky Tests and Broken Builds with Aviator. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farson. Victor, out of these couple of items, which ones do you hate worse? Broken builds or having flaky tests?
Which one I hate or like more?
Take your pick and just tell me which one it is.
Okay, I have bigger problem with builds because I know that I need to fix a broken build. With flaky tests, I just remove them.
So therefore, your test suites are basically a test suite with thousands of lines of comments, right? Or just remove them, right?
Isn't that better than false positives?
Well, I'd rather have a false positive, I guess, than a true negative. Anyway, why are we talking about this today? Today we have Ankit on from Aviator. Ankit, how you doing?
Hey, Darren. I'm doing really well. How are you?
Good. What we were talking about there is just a couple of the items that Aviator addresses. And we'll talk, obviously, if you've listened to our podcast, you know we're going to give the guest plenty of time to talk about what they're going to talk about. But we're talking about broken builds or flaky tests. Flaky tests are absolutely insane to me. Who was the genius that thought up flaky tests? Oh, wait. It's environmental, isn't it? Or is it? Ankit, what do you think?
I think this is an evolution. Firstly, Darian and Victor, thanks for having me here on the podcast. I'm really excited to be here. To answer your question, I think this is an evolution of where the code has come today. If you think about it, like when we started writing code, there used to be very simple tests, very simple infrastructures. As things get more complex, you have multiple different systems working together. That causes eventually some inefficiencies, some network issues, somebody writing also bad codes, dealing with lists, dealing with sets. Every programming language has different constructs. There are many different ways that flaky tests can arise. So unfortunately, this was not environmental. It's how the code has evolved. It's how programming has evolved. It's how a lot of testing capabilities have evolved.
Well, I don't know that I completely agree with you on that because flaky test can be network related.
It can or cannot be.
Can be.
Yes.
So, I mean, in those kinds of scenarios, okay, right. So we're in agreement on that. Okay. No big deal. No big deal.
Yes. So majority of the flaky tests really, I would say in last few years, a big rise in flaky test is also because of all these front-end programming languages becoming very popular, or frameworks rather, right? Like you have these Cypress tests, but on top of that, these React, Next.js, all these complex front-end applications weren't used to exist 10 years ago. And I think majority of the issues we see with flaky tests typically come from front-end.
So we can yell at the front-end people that they need to grow up and use a real front-end type thing like struts.
This conversation makes me so happy because I'm much more involved in backend. I can now just sit there and relax. Cool.
Well, backend is, Victor, not entirely away from flaky tests too, right? You also often delete these tests from your code base, so they clearly exist there too. It's just the intensity of number of flaky tests you get on front-end frameworks just tend to be much higher just because, now you have to deal with Chrome, which itself has its own challenges. But yeah, just there are so many moving pieces when you're dealing with front-end that causes flaky tests to happen.
And I'm guessing when you talk about flaky tests, not exclusively, but that's more applicable, more common with some form of testing that is from outside, right? Functional tests or something like that, rather than unit testing, right? Because then you're dealing with the browser, with networking, with API and all that stuff, right?
Right. It's more popular with
Popular or
browser
common?
for sure. Well, it's more more infamous with front end applications, but yes, like it exists in all shapes and forms, even in backend, right? Like you deal with like multiple infrastructure issues, but even things about like I remember very infamously we used to have this challenge where we would write tests for booking cleaning, and that would require understanding time zones. And clearly, like a test would pass in a particular time zone and would not pass in the other time zone. So those kind of challenges you can also have in the backend, right? So there are different colors of how these flaky tests exist in the world. And it's just front end. I just picked on front end because also not a big fan of it.
Okay, now this is curious. It might be interesting to maybe define what is flaky test, because after your last sentence, I have the impression that I'm thinking of something different than you. In my head, flaky test was more related to, I have a test that does this and that, maybe clicks a button on whatever, and then sometimes it works, sometimes it doesn't. We don't know, right? But the example with the time zone, that's very specific. That's not really sometimes does or sometimes doesn't, but rather that the test itself needs to include more variations, right?
For definition of flaky test, the way I would say is yes, in some ways you described it correctly as well. A test which, without modifying the code, can produce different results, right? It can produce a success, it can return a failure without modifying a code. In case of time zone, imagine you run a test at, let's say, 5 p.m. Pacific, which is actually, if I do my math correctly, that's already the next day in UTC. So now, depending on when you run the test, it may consider different times and actually produce different results. So like, for instance, if you're booking something in Pacific time, you end up actually booking for the next day. And it's actually, at the end of the day, it is poorly written code, which should obviously be fixed or deleted. But at the end of the day, these are the aspects that can create different outcomes.
Okay, enough about flaky tests. Broken builds. I mean, who loves a broken build? I see no hands and nobody responding, so that's good. What you've seen in Aviator, what are you seeing now as a big cause of broken builds?
That may cause a broken build?
Yeah. I mean, is it people just commit and run out the door? Which, okay, if the building's on fire, sure, why not do that? But what's the patterns that you're seeing from broken builds? Because obviously we talked about flaky test. A flaky test should break a build, right? That's a very sane and logical thing to happen. Yes. What are other things that break builds today?
So very commonly, the way we think about broken builds are many times implicit errors where multiple developers are working on similar shared code base, which is very common in today's team where everyone wants to move fast, right? Everyone is building a lot of features, but at the same time, developer collaboration requires some sort of segregation, because if you're working on the same code base, you may impact somebody else's code without knowing about it. And that's one aspect we see very commonly at Aviator, where implicit build errors, test errors are very common, where let's say you're modifying a function foo and somebody is actually calling that function foo in a different place. Now, if you modify the structure of it, you would want to change all the references of it. You would ideally do that, but at the same time, you can cause build failures eventually when both of them actually try to merge the changes. So that's a very common way where we have seen broken builds, where two people are working on related code base. There are obviously like many other places through which broken builds can happen. For instance, you can have issues with your infrastructure itself. Like, for instance, you're running a CI system on a third-party tool that may, have network connectivity issues where your builds may break. But those are the places which are more transient and it can be recovered. There could also be broken builds where you have dependencies on third-party libraries and those third-party libraries change, right? So there are many different ways of looking at broken builds. The primary one we focus at Aviator is around collaboration and identifying where all builds can break while all the developers have the right intention not to break them.
Let's assume for a moment, like this is one of those things that will never happen in real life, but that developers are actually talking to each other. I mean, even if they're talking to each other, right? We're assuming that is true. We don't know. Going back to your example, you got two people working on the same-ish thing, right? Enough to the point of having a clash. How do we try to manage that merging better, right? We could go back to old school days of using something like Visual Source Safe. Yes, kids, optimistic locking. I check out a file. I'm the only person that can work on that file.
Right.
And I can check it back in. And if I go on vacation, nobody can work on it.
Right.
Different decade. Actually, different century. But today, okay, so I think about it. We've got two people working on roughly the same thing.
Mm-hmm.
Number one goes in, and then number two goes in. But in reality, we needed two to go in before number one went in. I mean, how can people, other than communicating, how can people try to manage that a little more sanely?
Yeah, absolutely. I mean, this is where Aviator comes in as well, right? And again, these are some of the strategies that we have implemented at Aviator to solve these problems, also have existed for some time in many other companies. So we took inspiration from some of these companies, I'll just also name drop, like Uber, Airbnb, have built technologies like this to solve this developer collaboration at scale. So one of these concepts we call is merge queue, which essentially is instead of developers manually merging all these changes, you create a central entity that is responsible for validating all the changes and then merging them. I mean, like in simplicity, if you look at like, for instance, GitHub, which most people use, you can obviously like go and directly merge your changes. But at scale, what would happen is like as you gave an example, first person merged the changes and now the second person is trying to merge where some of the things have changed, but they've only validated with like an old version of the trunk branch. In this case, we actually ensure that we are updating your branch or we're validating the changes from a central place. And this merge queue concept is essentially the first time I actually heard about this was from a blog or white paper by Uber, talking about like how do you think about merge strategies at scale? And we've taken a lot of inspiration from that, plus talking to a lot of other companies at scale. How do they merge thousands of changes in a day where there's like, working on monorepos, where every developer in the company could be thousands of developers or actually using the same code base? How do you think about like scaling those systems? How do you think about like adding different layers of orchestration to ensure your builds never break? And again, the example I gave you was very simple. Obviously, at scale, there are many different strategies that you can apply, including batching and optimistic queuing.
Okay, I'm getting ready to pit you against Victor.
Okay.
I think. So somebody has to take one side, somebody has to take the other and argue for it. We're going to debate. Monorepo versus polyrepo.
End of story.
Who wants which?
Sorry,
well, no. We have to debate it. So, Victor, you have to take poly. So, can you take mono? Ankit, can you?
So, Victor, you're taking
for
polyrepo. Yes, I'm going to take monorepo for sure.
Okay. So let's debate it. Since Victor's been quiet, Victor, why don't you start about the positives of polyrepo and why people should be using polyrepo over monorepo?
Okay, I will assume that those people are working on microservices of sorts or separate applications, right? Not distributed monolith, not monolith, right? Simply everything is easier. It's easier to build because you know what you're building. It's easier to test because you know what you're testing. It's easier to push and it's easier to merge because you know what you're merging, right? Up to a level, right? There is always confusion. There are always issues. In my head, I honestly, assuming that we are talking about independent applications, independently deployable, which is a huge assumption, a massive assumption, right? But if I make that assumption, I don't fully understand what is the benefit of monorepo.
Ankit, how do you combat against that?
So the biggest advantage that we have seen companies adopt monorepo, in fact, well, let's just talk about biggest advantages. Think about standardization, right? Like if you're working in a company with thousands of developers, if you have polyrepo setup, managing dependencies, managing security compliance, managing how code is written in one team versus the other, right? Like all of those things become much more complicated. And on top of that, right, there is no single place who can help you manage your developer experience, developer velocity. Everyone is building their own tools. Every team is kind of like trying to manage their own systems. At scale, this problem becomes huge. Now, coming back to the other aspect, if you think about, look at like historically how companies have evolved. Most companies will start from a monorepo. Over a period of time, they will also get this itch is like very hard to manage in a monorepo. Let's split it up. They'll eventually split it up. And we are seeing more and more, like I can give you very specific examples, Stripe, DoorDash, or like these two companies who recently migrated to a monorepo. And the reason is the standardization. It's very hard for them to manage tooling and experience for all developers in one place. Think about like companies like Google and Facebook. From the beginning, always kept a monorepo. I think the challenges that you're describing, I would push back on saying is it's a tooling problem. It's not a philosophy problem, right? Like if there was a better tooling available for monorepo, you'd rather want to use that. Now, one thing I would give you an example, like a caveat is Git, I think, at least this is my opinion. And again, this is like a very opinionated opinion. Git is very hard to scale today. I mean, if you think about it, even systems like Google, today they have a layer of Git on top. But at the end of the day, they are actually like built from scratch to actually be able to scale. That is one thing which I've noticed now in larger companies who are using monorepos, where just using Git as a source control itself is getting very, very challenging at scale. And again, those are some of the advantages which you get by using polyrepos. But I think, again, that is a tooling problem than a philosophy problem.
Well, yeah, I agree on that completely. And I get slightly annoyed when I hear people quote Google in favor of monorepo, precisely because Google has the capacity, engineering, time-wise, manpower, to actually create internal tooling that make monorepo, when needed, behave as a polyrepo, right? But normal humans, I don't know, you want to adopt a pipeline, right? You're going to pick a pipeline, whichever pipeline solution you want. You're going to have trouble with monorepo, right? I mean, I know you can solve it with some regex in your pipeline that will say, hey, it's coming from this directory, that directory, but you have issues, right? You want to apply GitOps, again, issues. So I'm not philosophically or in theory, I'm in favor of, I think we should all use monorepos, right? It's just that the world somehow is, the tooling that you mentioned is not really built for that. Or let's say that kind of monorepo support comes second. It reminds me almost like of discussion Kubernetes versus Nomad. Yeah, okay, Nomad, great. There are many advantages to Nomad, but the chances that you will get a new tool that works in Nomad are low, right?
Right. And that's where we are like, there's a lot of problems to be solved here, right? That's why Aviator also exists too. And like, not just Aviator, there are many companies, right? There are so many opportunities to improve this tooling. Like, in fact, like many times we say, like, we are building. So I also used to work in Google. So I also sometimes say we build Aviator to provide that Google tooling to every developer. I mean, obviously, it's going to take us years, if not decade, to get there. But yes, there is definitely a lot of scope of improvement here.
Wait, you just said you're not going to be able to do this over a weekend? It's going to take years or even a decade? Or I'll add
I know,
on
like
more.
I know Git was invented over a weekend, arguably, but I don't think we can get there that quickly anymore.
Okay, I want to set up another fight. PRs or no PRs?
Wait, what is no PRs?
Meaning you commit direct to branch, trunk development.
I mean, commit directly to branch if you can pull it off, but that's like 0.1% of teams.
Well, it's not really a team; it's a solo person.
No. I mean, so look, if you, I would like to see your take on that, right? But if you're so mature that you really trust your tests, that you really trust your automation, that you really trust your coding skills, and so on and so forth. No, there's a huge list of fully trust this and that. I'm in favor of trunk-based development. It's just that it requires a certain level of maturity on all different levels that I don't think that an average enterprise has.
Right. I think kind of on the same bucket, I don't think this is going to be much of a debate. But for the biggest advantage of having a pull request is the visibility it provides for other people to provide feedback. And having some way of doing that is required. Like, I mean, you can also you still need some sort of like branching capability to while you're making your changes, because as you're making changes, you cannot just commit half-baked changes. You would want to still, fully develop it. But I can't imagine a world where you would not do reviews. Like, at least, okay, maybe I'm not, like, my hair is not that gray, but at least in my own career, I've not worked in a setup where you would not do review. I think there is definitely some merit to having that mindset of no reviews. I think it's probably, at this point, I feel like this argument is code reviews versus no code reviews versus pull request versus no pull request. But like one reason you would want to not do code reviews, it makes people a lot more independent. At the same time, it also kind of like puts responsibility on every individual person to make sure that they're doing the right thing. For instance, in case of a code review, sometimes you distribute your responsibility. Oh, this senior engineer approved my code. It should be good, right? Now you worry less about whether it's going to break something. Or even if it breaks something, oh, this guy approved it, right? Or this person approved it. So when you don't do reviews, I think that, I would say, cover disappears entirely. Now it's like everyone's responsibility to make sure you don't break anything. But I feel like given how fast the development world works today, it is going to be really hard to build that kind of a culture. But I think it is definitely worth a try.
How do you answer that in the context of the culture where people just do an LGTM on all the things?
I mean, that is the other side. You're right. A lot of code reviews happen very naively, in the sense you don't even look at the code. I think it is a little bit of reflection of trust. I would like, for instance, if I'm reviewing somebody's code, if I trust somebody more, I would do LGTM, versus if I don't trust that code as much, or if there's been history of breaking builds in the past, then I would probably review that code more carefully. I agree. I think this is to some degree a little bit of reflection of how trust develops in the team itself.
I mean, I agree, but except that I wouldn't say that trust to me is only a part of that story, right? To me, there are certain features that I'm interested in, and I'm watching those pull requests, right? Because I want to, maybe I'm involved in similar something, right? So it's not only trust, which is definitely part of it, but also understanding the code base, sharing the knowledge in a way, right? There are quite a few pull requests that I'm watching, or repositories that I'm watching it without really approving anything. Just kind of like, I want to know what's going on there.
True. Technically, if you're watching changes, you can also watch once it hits the trunk, or like once it's actually merged into the trunk. But yes, like I see, it still is one way for people to know what's happening in the...
I mean, when I said watch, actually, I didn't express myself well. Better word would be conversation, maybe, right? Kind of like we're talking about, we're discussing it in comments, so on and so forth, right? But yeah.
I mean, certainly, like when I write code, somebody needs to review it, because like, yeah, it's going to break something for sure.
I want to take us back to what we talked about earlier, the time where we had two merges and they went in backwards. Right? You can work your way around that. It's not a big deal. But now I go into GitHub or Bitbucket and look at my PR list. And just to be polite, I go into GitLab and look at my merge request list. I look at the list and I've got 25 PRs sitting there. How in the heck do I manage those? I've been using this word a lot, in a sane manner. Because I was just out on vacation and now I got back and people actually did work while I was gone. Go figure. And now I've got to deal with these merges.
Are you talking about reviews, or are you talking about merges?
Just at this point, the merges. Let's assume that I trust all the people doing the PRs. They've done all their stuff, and I'm the bottleneck, right? I'm actually taking care of the final, like I'm the final vote on all the PRs because of whatever my role in the team is, right? It's just a dumb thing.
Without reviewing?
No, I still review. Well, okay, no. I'll just say
you're not doing
LGGN
pull
because
requests.
everybody else has already done it. Right? Yeah, it's whatever. Okay, just look. I'm making up an idea here, and it's not going away. So, how do I deal with those? Because I'm going to have the same, if not worse, scenario in merging those PRs in than I did with just a straight merge to branch.
So this is where I find a lot of automations can help too, right? Like many of the places where these merges are to happen, right? If you imagine if there are, let's say, 25 PRs, not every PR or pull request or merge request is going to have conflicts or going to break the builds. So there are certainly many of these changes which an automated system can validate and ensure that it's not going to break the build and then merge the changes. The main aspect here to think about, or like one way to think about this, is instead of knowing that the build is going to break your main, master, or whatever you want to call your base branch, you can validate those things. You can essentially, in some ways, like look ahead in the future to ensure like anything that gets into the base branch has been validated thoroughly. Right? So what that essentially means in reality is you can either you can batch certain changes together and update with the latest base branch and then run validation and kind of like merge all of those things together. So in some ways you're acting as a gatekeeper. Now this gatekeeper doesn't need to be a human. That is what our main idea behind Aviator's merge queue is. All of these things can be automated. The only things that developers need to do eventually is if there is actually an identified build failure. One, we have already gated it from getting into mainline. At the same time, now you can actually inform the developer of this failure and have them take care of it, right? So when you come back from your vacation, all you have to do is like tell them, well, you still have to approve the changes, but if you trust them, all you have to tell them is go ahead and assign it to Aviator or assign it to a merge queue.
We've fixed all of our things. We've fixed our flaky tests. We've figured out our merge process. You have now eliminated me from my day job because now I no longer have to do these things. I mean, what is there left for me to do now? Right? Because it seems like automation has taken me out of what I was doing.
Why not say liberated you to do something that is actually useful?
Because I'm old and I have gray hair and I don't want to find a new job.
Well, you have to also keep in account the products like GitHub Copilot, which also now write code for you. So in some ways, this is the way I think about sometimes I tell people is maybe developers will turn into, artists, right? You think more about like doing creative things, maybe writing like specs about like what kind of systems, what kind of software, what kind of products you would want to build, and pass it on to AI or some machines or systems to churn out code, build beautiful applications out of it. At the end of the day, I think one thing which we all developers love to do is solve our intellectual curiosity. Because think about it, like nobody even wants to do all these like integrations with all third-party APIs. That's like one of the, well, there could be worse jobs, but like that's actually one of the bottom jobs in terms of creativity. But there is so many things that as developers, we can be creative about. I think that's what you'll be left with, Darren.
Probably. It just feels sad because we are not lawyers. So we'll see in 5 years whether or not the code written by AI is going to be held up or not. Different conversation.
I think that we have that conversation almost every year. When I was writing HTML in an editor, Notepad or whatever, and Dreamweaver came and kind of like you could just drag and drop stuff. And then, actually anybody can do that. I don't need actually to know HTML, which proved not to be true, but nevertheless. And since then, we get tools like that all the time, and we just learn how to use them to our benefit. Isn't that the point? Including Copilot.
I mean, at the end of the day, like as a carpenter or like not a carpenter or plumber, if you think about the work they do, they come and like fix a leak in your house, right? It's less about actually fixing the leak. It's more about knowing how to fix that leak. So I think that's where, coming the analogy back to developers, it'll be more about like understanding what kind of systems to build. At the end of the day, who builds those systems can be done by AI, can be done by automation. But like that curiosity part, that intellectual part, I think it will be really hard for artists to do, right? Like artists is not gonna, well, technically they're replicating Van Gogh as well with Dali, but to some degree, like it's not artists are gonna go away. They're gonna stay there.
Well, we'll see. So we were talking about AI. Are you playing with any AI in Aviator, or is it all just boring, punch the numbers type stuff?
Well, right now, most of the things are boring, punch the numbers, but we have started exploring capabilities around identifying, for instance, flaky test using AI, identifying like, what kind of things can cause build failures. Over time, we can also identify even before people are ready to merge their changes that this can cause possible build failures or like flag things which can cause those things. In addition, one other thing we also are exploring is understanding like how is the code evolving in teams, understanding like code ownerships. Those kind of things will also require some components of AI.
So the interesting part to this is as Aviator sees it and gets hooked in, it's like, hey, wait, you wrote this, but you really need to rewrite this. That's where I could see tools such as yours, where you're not on the, how do we say this? You're not on the left-hand side of development. In other words, you're not fingers on keyboard.
Right.
But you're also not at the point of it's been packaged and is ready to ship to a runtime somewhere.
Right. Yeah, the way we think about this space is like developer collaboration. It's essentially like where you need to interact with other people in the team. It's not a solo person working on a project.
So now we have a new person on the team that cost me effectively no money, that works 24/7, that can fix my code for me.
Yeah. Do you like it? It's also making your job less exciting.
As a manager, I would love it, right? Or somebody paying the bills would love it. As a manager, I don't know, because what do I do when my now AI person takes off and does the wrong things? We still need humans, right?
I think that you just said a key word, right? If AI is replacing our jobs, we still need developers to write AIs, right? If anybody's going to get replaced, that's managers. There's nobody to manage. Manage AI?
Therefore, that's why I will never be a manager.
Yeah, I think Darren, like your point is also valid, right? I mean, if you would always need some supervision, right? Like whenever, for instance, like whenever we also very actively use the Copilot, all the generated code, we have to always validate that it is correct. One thing I really like about Copilot, I don't know whether that's true for everyone, is like it produces really good code comments, but many times it gets like references wrong, variable names wrong. So those are some of the things I have to always double check. And I think you're right to some degree. That's the challenge with AI, that it's solving 95% of the problem, but you still need to validate all of those things to make sure it's correct and it's not going to break build again.
Right. And it takes us back to that. It does 95% of the work for me, but that last 5%, it may or may not get right.
Mm-hmm.
And it's in that 5% to where that's where we're making money for our companies, right? Because it's either working or it's not working. And if I can quickly get to 95%, heck, if I can even get fast to 50%, I'll take that.
Right.
Every day of the week. Again, ignoring all the legal stuff that will be coming out.
Or you can do 20 jobs at a time.
That would take another episode to talk about. So Aviator, the tagline on the site is aviator.co. Automate tedious developer workflows. Everything we've been talking about today. Broken builds. Dealing with flaky tests. Or needing to, as Victor likes to say, delete them. Probably shouldn't delete them. Maybe suppress them instead. Victor, would you like to weigh in on that one more time?
No, I mean, delete them maybe. So what I don't really want to have is common false positives that end up sucking more time than if I don't have automated tests, right? Now, whether the solution is something like Aviator or delete them or comment them, but I prefer having 5 tests I trust than 10 tests that I don't. Whatever the way to establish that trust is, without entering into that part, right? Because well, at the end of the day, if I don't trust my process, then I'm in deep trouble. And this is not only related with tests, right? This same thing like automated deployment, right? What's the point of automatically deploying something if I don't trust it and I need to go after it and actually watch it do something, right? Confirm that it's working well and so on and so forth, right? So yes, when I said delete them, I meant I don't want to have part of the process I don't trust.
That's a very valid point. Building that trust in test infrastructure is very important.
So what else can you tell us about Aviator that we haven't sort of poked and prodded at up to this point?
Yeah, I mean, I think we covered most of those things in bits and pieces. But one thing I would want to say is like we started Aviator because we saw inefficiencies in developer workflows. The way we think about Aviator is building a developer productivity platform that helps narrow that gap, that essentially helps all these high growth companies be able to scale their engineering workflows. And using automation, using AI, I mean, we talked about Merge Queue, which essentially helps teams manage parallel merging. We talked about flaky test management, which actually like helps teams manage the flaky test. We also have like essentially a layer of automation. And the way we think about this is like you can actually think of this as like almost a semi-programming language. You can essentially like configure different kind of like rules and setup based on your configurations. For instance, you can say like, hey, Darren, you haven't reviewed my code in 4 days. Every time that happens, I'm going to send you a Slack notification. So you can kind of like do many interesting things around that. That helps, automate many of these things. Otherwise, developers have to spend a lot of time doing manually. And that's where kind of like we see a lot more potential. And we talked a lot about like monorepos as well, where there is a big gap of tooling available today. And we're trying to narrow that gap to provide Google level engineering productivity capability for every developer there. So I think that's in a nutshell what Aviator is.
If you're going to be sending me a Slack message on every time I wasn't reviewing things
after 4 days,
for 4 days, then I'm going to mute that. So your next follow on to that is sending a Slack message to my manager saying that I'm not doing my job.
Yeah, it's like an on-call rotation.
That sounds funny, but to me, that's one of the huge problems that I've seen in many companies is that, and one of the reasons why some people are, hey, I against reviews and stuff like that, when people become bottlenecks, right, of that process. And that's really, really dangerous. I would go as far as to say, hey, if you're assigned to review this pull request and after 4 days, don't send him a Slack message, just confirm his name, kind of, right? Merge it without him.
Automatically
approve it, exactly. Because
right. Yeah. I think that's also an interesting opportunity that using AI, you can actually approve some of the simpler changes. And I think especially like, obviously some of the complex designs you still want to review, but like that's where also like intellectually curious work versus like really dumb approval work can be separated.
Yeah, it seems like that could be even tagged. The commit could be tagged a little bit differently when the PR goes in. It's like give it a tag, and it's like, yeah, or a tag basically is human only, right? So that's a scary thing to say, but if you have a human only tag on the PR, then a human actually has to do it. The bot can't make the final decision. Bot probably could make a vote on it, right? That would be a smart thing, especially if it finds something bad that it could automatically fix.
Yeah, one example, for instance, is there is a capability in GitHub, and I'm sure in GitLab as well, where you can dismiss a review when a new commit is introduced. Now, this is where Aviator or like any kind of like AI system could do really smart work, right? Like, let's say if you're just updating your changes and like adding some comments or adding some very basic scaffolding, you don't need to get an approval again. And these are the things we can easily also audit, at the same time also auto approve. Right? Like there are like these nuanced small things, which if you kind of collectively think together, can save developers hundreds of hours a year.
Not only save, but improve drastically quality. Because if Darren gets 5 review requests instead of 50, but 5 that actually matter, then he is more likely to actually review it for real. When I say review it for real, right. Spend some time, kind of, this is important, right?
Again, Aviator is at aviator.co. We'll have all of Ankit's contact information and the link off to Aviator as well. Ankit, thanks for being with us today.
Thank you so much, folks, for having me here. It was a pleasure.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.